Exercises T12.9 through T12.11. An old saying in golf is, you drive for show and you putt for dough. The point is that good putting is more important than long driving for shooting low scores and hence winning money. To see if this is the case, data from a random sample of 69 of the nearly 1,000 players on the PGA Tour's World Money List are examined. The average number of putts per hole, fewer is better, and the player's total winnings for the previous season are recorded and a least squares regression line was fitted to the data. Assume the conditions for inference about the slope are met. Here is the computer output from the regression analysis. All right, so of all the numbers here in the computer output, the only ones that we're really going to be concerned with are this one here. This is our B, it's the slope of the sample regression line. And then the one right next to it, this is the standard error of that slope, or we just call it SEV. All right, so 12.9. Suppose that the researchers test the hypotheses. The null hypothesis is beta equals 0. That means the true slope is 0, so there's no linear relationship between average number of putts and money earned, versus the alternative, beta less than 0. Okay? That means that there's a negative relationship between average number of putts and money earned. Right? The more putts you have to use on average, the fewer money you would make. Which of the following is the t statistic for this test? All right. So remember that a standardized test statistic is a statistic minus a parameter divided by standard error or standard deviation. All right, in this case, our test statistic will be a t-value. The statistic is b, the sample slope. The parameter is beta, the population slope. And the standard error is just represented using the notation SEV. Right? There is a formula for the standard error, but you're not required or expected to know it on the AP exam. All right, so we know what all of these values are. The sample slope value is here. The population slope value, assuming the null hypothesis is true, is 0. And then SEB is right over there. Okay. So let's go ahead and plug in these numbers. -4139198 minus 0 divided by 1698371. If you're wondering why these numbers are so large, remember that the response variable is money earned. PGA players make millions or tens of millions of dollars. Okay, so let's go ahead and calculate this. -4139198 minus 0 divided by 1698371. All right, so we get a test statistic of -2.4. 2.437, so 2.44. All right, so that matches choice D. All right, let's continue on in this video because the next two questions are about the same context. Okay. 12.10. The p-value for the test is 0.0087. Which of the following is the correct interpretation of this result? Okay, so to interpret a p-value, this works for any procedure. We would say something like, assuming the null hypothesis is true, all right, put the context there later, there is a p-value probability of getting the observed result you can put that in later, or more extreme, purely by chance. Okay, so just kind of glossing over the 5 answer choices, I'm immediately drawn to C and D, okay, because they both start with the phrase, if there is no linear relationship, right, which is saying like, oh, if the null hypothesis is true, right? Remember the null hypothesis says beta equals 0, meaning there's no linear relationship. Okay. All right, so let's kind of narrow our focus on those two statements. All right, so C says, let's have the sentence starter there as well. If there is no linear relationship between average number of putts per hole and total winnings for the players in the sample, the probability of getting a random sample of 69 players that yields a least squares regression line with a slope of negative blah 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 or less is 0.0087. Okay, so let's see. The null hypothesis is beta equals 0, no linear relationship. The probability would be 0.0087, and the observed result would be the sample value, which is that negative 4 million number. Negative 4139198. Okay. All right, so that seems fine. Let's look at the other one. If there's no linear relationship between average number of putts per hole and total winnings for the players on the PGA Tour's World Money List, the probability of getting a random sample of 69 players that yields a least squares regression line with a slope of negative 4 million or less is 1. Okay, so what's the difference between the two? Players. Oh, okay, I see the difference. This one says for players in the sample, and this one says for players on the PGA Tour, right? So statement C is referring to the sample only, and D is referring to the population. All right, well, I think D is the correct answer, right? Because we're assuming that beta equals 0, and beta is a population value. So we're assuming that there's no relationship for the population of all PGA players. Okay, so I'm going to go with D there. If there's no linear relationship for the players on the PGA Tour. Okay, good. So yeah, so C is incorrect because it refers to a sample, but our null hypothesis is about a population. Okay. Last question, 11. Which of the following would make the p-value in exercise 12.10 invalid? A, if the scatter plot wasn't perfectly linear. Okay, it doesn't have to be perfectly linear. It just has to have a linear pattern, but it doesn't have to be perfect. Okay, so I don't think that's the right choice. If the distribution of earnings has an outlier. I mean, if we saw an outlier in the residuals, then yeah, I think that might invalidate it. But just having an outlier in the earnings, I don't know. I'm going to put a question mark next to that one. Okay. If the distribution of earnings wasn't approximately normal. Okay, well, the only thing that needs to be normal is the residuals. Okay? The earnings or the response variable doesn't have to be normal. It's just the residuals that have to be normal. So I'm going to eliminate C. D, if the earnings for golfers with small putting averages was much more variable than the earnings for golfers with large putting averages. Okay, I like that one a lot. So what that's basically saying is, if we're looking at, putts versus earnings, right, and say there would be a negative relationship. Okay, it's saying earnings for people who have small putting averages are more variable, so that there's like a lot of variation here and then just a little variation here, right? And so what we would end up with is this kind of megaphone pattern, right, where it looks like this, okay? Which when you were to find the residuals, right, if you looked at the residuals here, you'd see very large residuals and then very small residuals, and you get what we referred to in class as that sideways Christmas tree pattern. Okay, so that's no good. So I'm going to go with D, but for completeness sake, let's read the last choice, E. If the standard deviation of earnings is much larger than the standard deviation of putting average. Okay, so there is a condition about equal standard deviations, but that's referring to the residuals. It's not referring to the original explanatory and response variables. Okay, so yeah, and then we said B was a question mark. Again, I think it would only be a concern if the outlier was in the residuals, not necessarily in the response variable or the earnings. So D is going to be the answer here.